Hello, welcome to my YouTube channel, Data Partners. Today I will show you how to delineate catchment area using HEC-HMS. HEC-HMS is globally recognized software, uh, expert used globally for their hydrologic modeling, and which is very portable and very useful software for experts, researcher, and for who is working in their project for where they are using hydrologic modeling for water resources management. Right. So let's start that. And before this, last in my last one of my video, I showed you how to delineate catchment using QGIS. So this time I'm showing by HEC-HMS. So this is also very good tool for delineation. It is very quick and very useful. And I think everybody should try this one also, because um, sometime your catchment area is flat, sometime it's a terrain. So and sometime sometime if you don't have QGIS, and you can use HEC-HMS, and if you know programming, then you can delineate by using Python also. So by using Python, I will show you in another video, but this time I am showing by HEC-HMS. So let's start that. So what we'll do is, first we will download from HEC-HMS download. Just write it on Google, and this will come up. And then uh, since I'm using Windows, so you can use beta version, and you can I use this one, download HEC-HMS 4.12 portable version. So I have already downloaded it. You just click here and download it, right? So then I will do is, once it's downloaded, so I put that downloaded um, software here, and because it will come in zip folder, and then I have unzip it, so I will just copy paste here wherever I wanted. HEC-HMS 4.12. So these files will come up by this. So what you will do, you will just click on this HEC-HMS. No need to install the software. You just copy paste the folder, then this window will come up. So before going I'm using QGIS, so that you will have some help to do that. So here I will I have a DM I have downloaded from from in the internet, from Google Earth Engine. I use Google Earth Engine to download this, and you can download it from USGS Earth Explorer as well. So this is my DEM. I have just opened it at this QGIS, and just go to properties. So you check here what is the so our extent is in latitude and longitude. You can we have in units is in degree. So so what I will do is, so I will just delete it from here. So let's start this. So once I will open this HEC-HMS, so first we need to create a folder, new. We need a basically we need to create a project. We call, let's say, CATCH, right? We call it Basin 1, whatever. And location is, I'm putting all the files in the HMS folder. So here you can use another folder also. So I will create in the same same directory. So I will create one, CATCH, catchment, right? So this will be my folder. So I will create it. So before that I did something wrong, right? I need to do it again. So I will just delete it. This catchment will delete it again, right? So because there should not be any confusion for everyone, at least basically for the people who are beginner. So let's start this. So I will click here, HMS, and then create new project. We call basin 1, whatever you can write basin or basin 1, let's say, and then mm, go to give it to path, this HEC-HMS, and then I will create a new folder HM, right? So it will come, and default unit system is US customary, but I will put here metric. That's what that's the create, right? Then go to component and go to basin model manager. You create one name or basin model, create one, right? So this is created. Now, because we have to put the terrain data. Right now, we don't have any terrain data here. So what I will do is go to component, then we'll go to terrain data manager, where we will include the DEM. So we'll go to new terrain one. You can put another name also, but I will prefer this terrain one. Next, put the DEM. So where is my DEM is? Somewhere here, wherever you have. So I have DEM here, right? Vertical in meter, finish, right? So terrain data also included. But thing is that, but here in my basin level, I need the terrain data. So I will put here terrain one, right? So then I will click on terrain. So you can see basin model coordinate system. Now, I showed you that I have this DM have lat long is in degree, but our unit we have defined in meters. So better to have our coordinate system should be in meter. So what I will do, if you have if your data, if your DME already in the UTM, then you can skip this. But our data is not in UTM. So then go to select and predefined. So standard hydrologic rate, no. Universal transfer marketer. So uh, my DM zone is 44 and northern, and datum is WGS 84. Select, then set, right? It means no error came here. Means you can see here at the down. If no error is coming, then it means everything worked fine. So then I will go to basin and I will select here terrain, and now then click it to the terrain. So um, uh, my DM comes here, right? So what next? Then we will go to GIS. We need to do some GIS pre-processing here. We call it pre-processing. So there are coordinate system, terrain reconditioning, and pre-processing, pre-process drainages and identifying. A lot of things are there. But thing is that we will do whatever is required at this moment. So we will go to pre-processing. So terrain reconditioning is required when you have already the catchment area, and you have any catchment boundary, if you have any existing boundary, and if you have river stress, digitized river stress, because this is useful when terrain is flat, where elevation difference is minor, or very less, means less than 1 meter, or point 0.5 meter, like that. Because in that the delineation of catchment is very tricky. So we can do that also in later stage. But if you have elevation difference is more than 1 meter, 2 meter, 3 meter, then it is not required. But better. So what I will do is I will go to pre-processing. So let's check it. So pre-processing, will click it, then uh, it will like that. So it will take few minutes. Yeah, it's done. Means you can see a lot of things, it process the things. Then we'll go to pre-process the drainage. Now it will pre-process the drainage after sink, because it automatically it done, and then now it will pre-process the drainage based on the all the he already filled the sinks, and based on that it automatically delineate, or automatically pre-process the drain system. So it may take some time, because it all depends on the length of uh, your DM. Sometime, that's why, sometimes GIS softwares are required. If you have large area, and heavy D, then the DM will be very means large. The size of the DM will be very large. So that in that case, you can use QGIS or ArcGIS or any other software for delineation of uh, catchment area. But if you have uh, catchment area is if your DM is not big, then you can use HEC-HMS in a right way. And because that actually it all depends on your computer system, your system also. If your RAM and you have high end computer system, then the processing will be fast. So that's why and so it may take some time to do that. And so in my last video, I showed you that how to use grass tool in QGIS to delineate the catchment. And in next, and this one is by using HEC-HMS. So, and in next video, or I will delineate the catchment by using Python scripting, right? And there are some Python library, PySheds, and other. So those are very useful. So when we now it's done. So when we did this pre-processing the drainage, it means then it calculated the flow direction, flow accumulation, right? So based on the uh, based on the DM, so flow direction based on the flow direction, it calculated the flow accumulations, right? So you can zoom in, zoom out, everything you can do, right? Yeah. So now what I will do is because it's a lot of drainages are there, so we will more refine it. We'll go to GIS. Now we will identify the streams. Just click here. So area to define a stream means the least area is 259. So I will put 500. You can put 1000 also. You can put it all depends on how much area, how big your catchment, how catchment or how big is your catchment, and based on that, in how much square kilometer you want to do the you want to delineate the streams, right? So okay, so uh, let's wait for this. So you can see, so it already delineated the, you can see this yellow line, right? So I will just so it this way. Yeah, yeah, you will zoom it, you will zoom it, right? So you can see, so it delineated the stream. If you put less than 500, then maybe you can see other drain also, right? Other drainage or other streams. Sorry. So what I will do is, then next I will go to GIS, and then we have already identified the breakpoint manager. This is the pour point actually. At that point where we would like to delineate the catchment. So let's do here. What I will do is I'll put somewhere here in this part. Any point you can put this, and yes, breakpoint create, right? And then delineate the element. So you just put subbasin. You can put S, reach R, insert this one is yes, and this J, all right, and then delineate. Let's see. Yeah. So it's delineated the catchment area of this at that particular, and you can put any other point also. So this is the catchment area. Because after that we can add points, junction, reaches. That is different. Means the actual the modeling HMS model setup. But I'm not going to that in that part. I'm here only doing the catchment delineation. So so what you can do is you can do the GIS and export layers. And before that, you can see here, if you go to view, In the map layer, you can see all the sub basins, you see sub basins, right? And you can see the breakpoint also, this one, breakpoint, right? Identify streams. You can off on off all the layers, means those files, flow direction, flow accumulation, and everything you can. And those are stored here actually. If you go to catchment file, you have basin one, you have terrain one, you can see this elevation, flow accumulation, flow direction, all the raster files stored here, right? So you can use further those file if you need that. So go to GIS export layers, because if we need submission in GIS format in save file, then next, and go somewhere here. So what I will do is we'll put that in the catchment area. We have maybe GIS file, GIS. I will do the Basin, Basin boundary. So save it and finish. Right. Then go to QGIS. Let's say I will open this DM, and then I will open that file, the catchment boundary. Go to this one, catchment basin, and this one is what I did, shape file GIS. Yeah, this basin boundary. Open, add, close. So you can see you have basin boundary here. So what you can do is, now you can do all the analysis, visualization thing. What I right, and put some line, yellow line here, right? So this is your catchment area, right? And you can clip this this particular catchment area, and you can do a lot of analysis. You can clip the land use file out of it, and you can do the hydrometeorological data analysis for this one. So there's a lot of analysis you can do here. And in my last video, one of my I showed you that how to calculate area of this file. Maybe let me check whether it has given area here or not. Go to attribute table. Yeah, it has given the area also. The area square kilometer, 961 square kilometer for this this catchment. And in my last video, I also showed you that, in my data partnership, this one, Python GeoPanda 3 visualization and area calculation of a special type of GIS data. So you can do all the things or analysis by using GeoPanda. So you can refer this one also. So guys, I think this is that's it. Actually, I wanted to show you that how to delineate catchment by using HEC-HMS, and you can use your own DM for this, and uh, practice it, and let me know if you are facing any difficulties to delineate the catchment. I will be happy to help you. Right? Thank you very much.